ANOVA using Jamovi. First, let's discuss what is one-way ANOVA. The one-way analysis of variance is also known as single-factor ANOVA or a simple ANOVA. It is used to determine whether there are any statistically significant difference between the means of two or more independent unrelated groups.
The one-way ANOVA is like the extension of independent samples t-test. So if you want to compare means but you have more than two groups, then you can use the one-way ANOVA. But before doing the test, make sure to check the following assumptions. First, your dependent variable should be measured at interval or ratio level. Second, your independent variable should be consist of two or more categorical independent groups. Third, you should have independence of observations. Fourth, there should be no significant outliers. Next, your dependent variable should be approximately normal distributed for each category of independent variable. Last, there needs to be homogeneity of variance, Levin's test. If your data fails these assumptions, Welch ANOVA can be an alternative.
One-way ANOVA is a collective test statistic and cannot tell you which specific groups were statistically significantly different from each other. It only tells you that at least two groups were different. To determine which of these groups different from each other, post-hoc analysis is needed. The shift test is customarily used with unequal sample size, although it could be used with equal sample size. The Tokay test is only used when the sample size are the same.
Here is an example. A researcher wants to compare the effects of three different types of fertilizer on the growth of corn plants. The researchers randomly assign the 10 corn plants to each fertilizer treatment and measures the plant's height in centimeter. At the end of growing season, the following table shows the data. The independent variable is the type of fertilizer and the dependent variable plant growth in height centimeter. And the null hypothesis is there is no significant difference in plants' mean height among the three fertilizers. Since the dependent variable height is measured in ratio level and the independent variable is a type of fertilizer that is categorized, we have met the two assumptions, which is 1 and 2. To start the analysis in Jamovi, create the column that will divide the fertilizer type in the height. Make sure to label the independent variable nominal and dependent variable continuous. To check the outliers and normality for each type of fertilizer, go to Analysis Exploration and Descriptives. Transfer the dependent variable height in the variable box and the independent variable type of fertilizer split by the box. To check the distribution, go to the Statistics, drop down the panel and check Shapiro-Wilk under the Normality option and unselect unnecessary measures and look at the right to see the result, the p-values at the bottom. Note that if the p-value of Shapiro-Wilk test is greater than 0.05, the data is normal. Now, since all the values are normal, that is greater than 0.05, therefore the data set is approximately normal distributed, but if your data failed this test, you may do the Croscoe-Wallace test as an alternative to one-way ANOVA. Now, to check outliers, select the drop-down panel plots and check box. By checking, we can see that each plot contains no outliers. Here are the fertilizer groups. Next step is to run one-way ANOVA where the homogeneity assumption can be checked. Go to Analysis ANOVA. In one-way ANOVA, select the dependent variable and transfer to the appropriate box. And transfer the independent variable fertilizer in the grouping variable. To check the homogeneity, select the homogeneity test under the assumption checks option and Jamovi the default in Levin's test. Note that if the p-value of the Levin statistic is greater than 0.05, then the variances is not significantly different to each other. This means that homogeneity assumption of the variance met. In our example, in the Levin statistic, p-value of 0.0704 is greater than 0.05, then the homogeneity assumption of the variance met, so select the Fisher test under the variances option. Now, we will decide whether we'll reject or retain the null hypothesis in the problem. The analysis of variance showed that the difference between groups was statistically significant because the p-value 0.04 is less than 0.05, rejecting the null hypothesis. Since we rejected the null hypothesis, we will perform a post hoc analysis. We will select the Tukey test because all three groups have equal sample size in variances. Church-Levin's test. In the post hoc table, the mean difference between A and C is negative. The third group has higher mean than fertilizer A. To check the significance, the comparison A and C look at the p-value. Their differences are significant if the p-value is less than 0.05. The Tukey table only fertilize A and C shows significance since the p-value is 0.033. To explore the results, select the descriptive table under the additional statistics option. Here you can see the mean and the standard deviation of each group. The interpretation with post hoc analysis. The analysis of variance showed that the difference between groups was statistically significant. Post hoc comparison using the Tukey test indicated that the mean height of plants under fertilized is 27.4 was significantly higher than those under fertilizer A. However, the mean height difference of plants between fertilizer A and fertilizer B and fertilizer B and fertilizer C did not differ significantly.
That's it for today. Thank you for watching.